Example 71, PDF or probability density function is given, asking find the mean and the variance of y. Okay, what is the mean? How do we find the mean of y? Expected value of y, this equal, definition is negative infinity to positive infinity y fy y dy. For our case, y greater than or equal 0. Therefore, negative infinity to positive infinity y time y e negative y dy. So we can do this negative infinity to positive infinity y to power 2 e negative y dy. So now we need to integrate this. But before we integrate, let me write or tell you one thing here. This is PDA, probability density function, and y greater than or equal 0. Y greater than or equal 0. Therefore, we should know this 0 to infinity y e negative y dy equal what? 1. Okay. So if you know this one, you can integrate this one easily. Let me show you. Right. So how do we integrate this one? We need to get the uh, by parts method, right? So what we do, I use u equal y to power 2, then du equal 2y dy, and next dv equal e negative y. From this v equal negative e negative y. So we can use by parts here. So negative y to power 2 e negative y 0 to infinity, and plus then 2 times we have 2y dy 0 to infinity y e negative y dy. Right. So this one you know that is 0. But what is this part? So you see I write down over here, that is the same thing, right? So therefore you know it is 1. So this is 1, then here 2 is here, therefore 2 times 1 is 2, and 2 plus 0 2. Therefore we can say expected value of y equal 2. Okay, let me write down here expected value of y equal to, right. Suppose you you didn't get this part, okay, you couldn't figure this out. So then actually again you have to integrate, apply the by parts method for this one to get the answer. Okay, right. Now asking variance of y. How do you find the variance of y? Right. There are two methods. First one is you get the variance of y by the definition. Variance of y equal expected value of y minus mu to power 2. So by the definition, expected value here y goes 0 to infinity, right? 0 to infinity. Therefore, y mu equal 2, we already know that, and fy time y e negative y dy. So you can integrate this one. Actually, sorry, this one should be second power, right? You can integrate this one. Okay. If not, this is the first one. You can use this method. What is that? I think this is easy. Variance y equal e y to power 2 minus e y whole power 2. We already know this part, expected value of y. We need to find the expected value of y to power 2. So we know by the definition that is 0 to infinity y to power 2 y e negative y dy. Alright, so here you have y cube e negative y dy, 0 to infinity. Right, so let me tell you something here. Expected value of y for this case equal what? Y then time py, right? Then this become y to power 2, right? E negative y dy 0 to infinity. So keep this in mind, okay? It's very helpful, believe me. Right, so next one. So now we use by parts method for this one. So u equal y to power 3, therefore du equal 3 y to power 2 and dv equal e negative y. From this v equal negative e negative y. So apply by parts, then negative y to power 3 e negative y 0 to infinity plus 3 0 to infinity y to power 2 e negative y dy. Okay, so here you see this becomes 0. And how about this? What is this? Actually you see this one. See, 0 to infinity y squared e negative y dy, right? So that is ey. So this is ey. We already know ey. Ey is 2. You see that we know already ey. So 2 times 3, 6. Therefore you can write expected value of y to power 2 equals 6. Right? We almost done. Variance of y equal expected value of y to power 2 minus e y whole power 2. So 6 minus 4 equal 2. So variance is 2. So what is the standard deviation? Standard deviation of y equal square root of 2. Okay.